Welcome back to Maya 2017, and in this class we're gonna finish out our mini project that we started last week. So let's dive in. File, open scene, navigate to your project directory where you save downloaded from a FTP example file for the class number 3. The file name is a trail_01.mb. So first of all, let's take a look what we have in Outliner. In Outliner we have a fluid container. It's just a basic fluid container. As you see, it points in exactly the same direction as you would create if you would go to fluid, create 3D container. It was not rotated in any fashion. Its rotation value is to 0. Okay, and then I have a fluid emitter, traveling or animated, moving in 3D space. So if I take this guy, and there's a sphere that is actually parented under the same animated group. So display, show, selection. And if I play back, you would be able to see it's moving right here. Okay? So I think it's very simple. I have a group. Under the group itself is animated. If I open Windows Animation Graph Editor, right? And I got first frame here, and it moves along X positive direction. Show grid, you can see on negative X direction like this. All right. Okay, so it goes from here to here. Very simple. And only the group is being animated. Under the group we have a sphere, and the sphere is NURBS, which could be a geometry, any other geometry, polygon and such. And I selected this piece of geometry, and I say particle emit from object, and I selected surface emission, and I said right now, well, this is the, okay, it doesn't have to be 0, but it could be. So you say emit from object and you emit particles. Okay, so let me illustrate this concept. So delete. So what I did, create NURBS sphere. Okay, it's right here. Then I grouped it, Control G. Now you have a group under NURBS sphere, right? This. So instead of animating sphere, I animated the group. So let's say I have 200 frames like this, and on frame number 1 I said key selected, translate X, and I want to frame 200, for example, which in that case was 150, frame 150, and I moved it along negative X. It could be any direction, it doesn't matter. So I open the graph editor and change this slope graph to linear, both of them to linear like this. So it moves with a consistent speed. It does not decelerate or accelerate. So group is animated, sphere is not. Sphere is moving because of the group above it is being animated. Then I wanted to emit particles from this sphere. The sphere is the representation of the fluid emission. Okay, so I go to particles and say create emitter, and say particles emit from object, and I say surface rate 100. You always able to change it later, and speed 0, speed random, tangent normal. You can zero everything out. So if you hit apply and close and play back, you can see it playbacks faster than real time. So I select this and play back. Okay, so the particles emitted, but they're not moving because we're not giving them any speed. So what I want these particles to kind of distribute it kind of around that emission point, like around it, like let's say a distance of one sphere all around it. So I go to the particle emitter, that is parented automatically under the piece of geometry that used to emit it, right? Let's darken the background. Okay. And here I say that the speed, for example, is 1, okay? And I will also make sure that normal speed is 1, so it emits them along normals. So they go along normals, okay? Okay, and now I say that speed random. Let's select the group, okay? Channel box, right click and say mute selected like this, okay? Playback, and you can see the particle all moving the same speed. What I want, they move to with different speed, because I want one particle to be further away, another one is closer to the emitter. So I would like to kind of create a cloud of not moving particles or very slowly moving particles, but I would like to fill that area very fast, like immediately. So what I want, I select emitter, attribute editor, and I say that speed random is equal to 1. So what happens when this value is like this is that speed random value is plus minus to speed value. So the slowest particle will be traveling with speed of 0. The fastest particle, 1 plus 1, will be traveling with 2. So rewind to the beginning, hit playback. So that's what we got. The fastest particle is already here, even while they just start moving. But there are some particles that moving quite slow. Okay, so now what I can do, I can say that inherited the conserve is like very low, meaning like the particles, no, that's too low. The particles lose momentum really fast, like this. So you just eyeball what value is. You can return to emitter and give it like a larger speed 2 and 2. When you, since you would like to like as random motion as possible, you kind of, so you got the idea, is that the particles emitted in all different fashions. So even if on one single frame of the emission you already got some kind of random numbers, one is further than another, right? So like this. So I can now select the emitter and increase the rate, for example, to 100, like this, right? So a lot of particles emitted moving in that thing. We see the pattern here. That's actually happening, like emission pattern of the particles here, right? Is because the geo connection, you need to increase the tessellation, but that's not subject of this conversation anyway. Okay, so we got this. We can now unmute sphere, unmute selected. So now let's play back. So imagine this is our fluid emitter traveling through, let's say if I create a cube, sorry, create polygon. If I create a cube like this, okay, so this, the cube represents the fluid container. So this guy is flying through the container, and what I would like, and center of this sphere, inside of this sphere is emitting fluid, temperature, and the density into the fluid container. Then each particle, since it's emitted along U and along the normal of the particle, right? It remembers that value. It knows what the velocity is, and we can read that information even while the particle stop moving or moving very slowly. We still can take this value stored in a particle, like if I select the particles, let's reduce the number, let's say max count to 10, right? So if I play back those particles right here, let's say, and I go to numeric under the shading attributes, numeric current type, and I say instead of that velocity, like this, right? So even while the particle is not moving, it's kind of remembers all this data here. It's kind of represented. So we can turn this into the force, and we can use the direction that the velocity vector represent that we covered in the previous class into the direction of the force. So that quickly brings us into the conversation about how do we make particle force of our choice. So for this we do following. First of all, let's delete this cube and create a real fluid container, like create 3D container here. Okay, under display I want to make sure that we don't see fluid particles and bounding box instead of like grid. Okay, so, and let's hide the grid. Okay, so I select fluid container, go to fields, okay, and I say assign gravity to it. So what happens is that the fluid is now being affected by the regular gravity field, and it's the same thing we covered in the previous. I would go ahead and zero all built-in gravity forces inside of the fluid container, and that regarding the density and the temperature. Okay, so I zero both gravity and under the temperature content details, temperature, buoyancy to 0, which is the temperature of gravity. So this fluid container on its own emits no velocity. I mean, there's no force acting inside of the fluid container. The only reason why there will be any force on this fluid is the gravity field that we just assigned from a field menu. Now we can select gravity field that we just created, and we can select with shift select particle. So both gravity and the particles are selected. Now you're going to field menu and say use selected as source of field. When I hit this command, the gravity field will move and parent it under the particles in outliner. Bam, you can see it happening here. So the gravity field, this what we see here is not really child-parent relationship. It's just a way Maya displays that there is a relationship between this particle and this gravity. And usually, if let's say gravity force is controlling particle, you won't be able to see this type of representation here. That's something very unusual when the gravity or any other force is placed as a child to the particle. It's actually a special type of relationship here happen. Once again, we use a field, use selected as source of field. So what happens when we do that is that each particle, each point now there is turned into the gravity field, meaning like it is, each particle is a source of the gravity field. But since our gravity field is kind of infinite, then it does not really matter. All we end up with just like a, how many, 10 particles here, 10 infinite gravity fields. So we need to make sure that each gravity field is actually got some kind of distance limitation, and we do that by selecting a gravity field, going into the distance, and say use max distance, right? And you specified here the max distance for this particle, for this field is -1, meaning like it's infinite. You say, for example, 1. So with value 1, the gravity field will be a radius of 1 around each particle. So each particle is now a gravity field. The particles still are particles, so they do all kind of usual particle stuff, but on top of it, they also work as a gravity field. If we would do it to uniform field, if we build relationship between uniform and a particle field, each particle would be uniform field, and so on, Newton and so far, right? So in order to make sure that we finish this setup, we need to select field, and that applicable to every field from menu that you create here. Go under special effects, and there's a hidden attribute called apply per vertex. Only with this particular attribute we make sure that whatever we're going to do is working. So once again, it's a two-step process. Select force, shift select particle, go into fields, you select it as a source field, under select force, under special effects, apply per vertex. After that, you don't have to connect particles and fluids like you usually do. For example, like emit from. So there's no need for relationship between the particles and the fluid. The particles that act as a field to the so if we go into Windows, relationship, and we say dynamic relationship, and we select the fluid, then we would be able to see that fields, right, fluids on the left, and the entities that is a fluid connected to is only gravity field. Right now there's only one relationship with the gravity field. Okay, so that's clear. Now we also specify the maximum distance here, but if we would leave this attribute as is and just will keep using this preset, this setup, we will end up with the gravity attributes that apply to every particle. What would be cool if each particle would have its own, for example, magnitude value, its own max distance value. So each particle acting as a completely independent field, gravity field, with its own magnitude, with its own direction, and with its own radius. Not radius, but maximum distance. And it's very easy to do. All we have to do is to select particle, go to particle shape, and say add general, new, and that's actually something that I touched in the first class where I mentioned how to create per particle magnitude attribute for the field. It's exactly the same idea. So you take a name of the field, let's say gravity field. It needs to be spelled exactly, right? Like this, gravity field at 1, we underscore, that's required, and then we type the name of the attribute itself. Okay, so the attribute that you find under the field shape node. So you say, if you really not feeling confident of doing it by its own, you can select field, right click on the attribute, say create new expression. Create new expression gives you the name of the attribute. Syntax is right here. So you select it, copy, close that, don't create for the field. All you needed is just the attribute syntax. Now select your particle, say add attribute. You want to create per particle attribute, right? Add initial state if you want to, and paste the name of the field attribute. And you see gravity field, name of the field, magnitude. But we want to replace the comma with underscore. So for the particle to work, this is mandatory syntax. If you mistype it, you still will be able to create the per particle attribute, it just won't work. So it's important to keep it right. So magnitude with attribute corresponds to the same name of the emitter attribute called magnitude. That's how Maya will find what particle attribute affects what field. So for example, if you want to per particle control max distance attribute with each particle, then you right click and say create new expression, copy the name of the attribute, return back to your particle, hit general, per particle, add initial state, paste the name of the attribute, and underscore max distance. Now you've got this. You can see you already created two gravity attributes, and since the syntax is exactly like in a field, then they will be linked together. Okay, and the last attribute that we would like to use, so we create max distance, magnitude. Now we would like to direction, because we would like each particle to have its own velocity vector pointing away from where it was emitted from, right? So it's practically along its own velocity vector. So we select field gravity, right click and say create new expression, just we want a syntax, and you can see it's not just a direction attribute, it's a direction X, and it's a direction Y and direction Z. So we need to create three per particle attributes, right? And each of them would be a float, not a vector. So we can create one vector attribute for X, Y, and Z direction. We need to follow exactly same syntax as it's used for the field. So if the field attributes broken down by three float attributes, which is a direction X, direction Y, direction Z, we would have to recreate exactly same setup for the per particle attributes. I hope that's clear. Okay, so you select particle, you select general, and you go ahead and copy paste, and you create new attribute underscore X, right? Capital X, like this, and we make sure it's per particle float, add, and we do it for Y, add, and we do for Z, add. So we end up with three attributes right here, right? So X, Y, and Z that controls. So once again, each particle is a gravity field with its own radius. Okay, so if we, for example, switch from numeric to spheres like this, our spheres has got some radius to them, right? So we can say general particles, and let's say radius pp. We add per particle attribute radius pp, and we say creation expression, right? Copy paste, and we say radius pp is equal to random between 0, let's say 0 and 1, like this, right? And since we know that if we emit first number, then it defaults to 0, so we could achieve the same with the shorter line like this. Okay, so this particular expression will make a particles with random radius that would range from 0 to 1. You can see the smallest particle right there. So now we can say that each particle could have, since each particle here is used to become a gravity field inside of this fluid container, right? Then we can say that radius of each particle will be really the max distance for the gravity field. So I say copy max distance attribute is equal to radius pp attribute. So by doing so, whatever we see in the viewport here become a good representation of what the boundaries of the gravity field will be. The only thing, the magnitude for the magnitude, what we can do, for example, we can map it to the life of the particle. So it's full at the beginning and it dies. The magnitude of the velocity of that gravity field that is being emitted into the fluid diminishes over the time and zeros at the time the particle dies. So for example, if I change lifespan pp only and I right click on lifespan pp to create a creation for that, and since I already created expression for that, I don't have to create new expression, just use the one that already exists. So I put particle shape bp, shape lifespan bp is equal to, for example, particle lives for 4 seconds. Okay, so 4 seconds, we specify it's in the seconds. Okay, close. So now if I play back, each particle will live for 4 seconds, which is 4 by 24 multiply is equal to 96, 24, 24, 48, 96 frames. Okay, they all died 96. But what we can do now, we can right click on gravity field magnitude and say create ramp, and it automatically maps to life. And you can say edit array mapper, and here you can specify the minimum and maximum values. So the maximum value for the ramp, we say the maximum value is a 10. So when the particle just burned, the gravity field is equal that the particle emits is equal to 10, and when particle dies, close to die, it will be 0. You can change those numbers when you shape your simulation. So let's switch back to numeric field. Numeric is a friend. It displays you everything you want in real time. So you say gravity field. So if I say create expression, find that name of the attribute, which is a gravity field magnitude right here, right? I can copy it and paste it into the attribute name like this, right? So if I play back now, you can see how this number diminishes over the life of the particle. And this number right now represents you how much each particle will be injecting into the fluid container, how much velocity it will be emitting. But once again, back to beginning of this conversation, is that the gravity field is the field that allows us not to disturb the fluid simulation. Okay, so let's go back to that scene that I specified that I will be uploading, and you will be able to see that's exactly what I just showed you. So it's a transform node with the sphere in it that is defined to layer here, right? And a particle emitter as a result of me being emitted, right? I emitted n particles because they're multi-threaded, meaning like simulation runs on multi-cores, still pretty slow, by the way. And so it needs to be very delicate with the particle acting as a field. Okay, and now there's a fluid emitter that was created by selecting a fluid container, going to fluid effects, add emitter, just like normal thing. And a fluid emitter just a point, but you can easily display it as a sphere, like a spherical. It's omni, but it's given a max distance, which makes it would be the same as saying it's a volume, right? But change it to sphere and giving it a radius. Given it a radius of maximum distance, it was, right? So you got the point. It's a pretty simple thing. Okay, so once again, let me reopen that one. So the emitter is a fluid emitter is omnidirectional, but since we're given it a max distance value, it acts as a sphere. So we could visualize it just a ball, really. So this sphere that we use as a particle emission, okay, as a particle emission sphere, is actually a good representation of radius of the fluid emitter. Okay, so and we emit the particles from a sphere, and they move in exactly the same fashion. So if I hide the fluid container so we can see playback, and I play back, you can see those particles moving exactly what I just described, except they live for 2 seconds, and I gave them transparency just for visualization purposes. And if I select the particle, I open the attribute editor, and under the dynamic properties, under the per particle attributes right here, you can see direction Z, that's for gravity as we just discussed, direction Y, direction X, radius PP, that is being used to with the max distance. So the gravity max distance is linked to the radius PP. The magnitude mapped to the ramp, that is mapped to life of the particles, because lifespan is lifespan PP and given 2 seconds. Okay, so you can always create an expression right here, and the expression right here, nothing fancy, right? So that's it. Radius is given here, and I believe there is not even runtime or after. So what is actually happening here, that the only thing that I would like to point is that the direction to the velocity of the gravity so each particle is given its own direction. So when fluid density and the temperature emitted from, let's say, fluid emitter, which is kind of share the same center as this sphere, then they wouldn't move at all. The density and the temperature would not move at all if not the particles that act as a gravity field. So as fluid is emitted right here, you can see it here, that yellow ball, that's where emitter emits temperature and density. But if I would delete particles from a simulation, all we would have is just a ball not moving at all. There's no other force than those particles, okay? And those particles, they kind of radiate away from where they were emitted, from the normals of the sphere, and that's what we discussed. They're flying away, and as this fly away, they don't really fly too far. They just sit there, like here. So they're not really moving. But even while they're not moving, they emit a lot of force into the fluid, meaning like even not moving at all, they emitting a lot of velocity into the fluid container, making all of this smoke radiating away from the path that they were emitted to. So giving us completely different look comparing to effect that was achieved with the temperature alone, temperature turbulence alone. So comparing this effect here to that simulation that we have here, that is result of the noise in the velocity. Okay, and another thing that I do here, I dissipate the density quite fast, and that's because I would like to keep the container size small enough. So if we take a look at the container here, what's actually happening is that if I, for the purpose of this simulation here, disable simulation, and I play back, you can see that I wrote expression. You can access it under animation, expression editor, and by expression name, pShape. What that expression does, it slices away the fluid expression, since you can display it. That's particle expression. That's scene one. Strange, I don't see there. That expression is really secondary. It's not really linked to the simulation. It's not affecting simulation. All it does, it slices fluid container 4 voxels at the rear at each frame that after frame 45. So as a sphere or emitter approaches the boundary of the fluid container, the expression kicks in on frame 50, and I just eyeball that. I knew that it's going to happen on frame number 50 because I looked and analyzed the simulation. So on frame 50, I noticed that the distance between the emitter and the wall of the container is really small, and I started to, on each frame, remove 4 voxels on the back of the container and add those 4 voxels at the beginning, toward the motion. So what happening is that resolution of the container remains to be exactly the same, 2790, but since I removing and adding, it kind of, it moves in 3D space, right? So when the reason is because I don't have to have like one gigantic long container like this, in order to accommodate the simulation. But in order to keep the simulation time small, I need to make sure that this length of the fluid container is enough to make sure that it's not visible, that it dissipates before the hidden boundaries. And we can see that my quick attempt to do the simulation in the smallest container possible failed a little bit, because we can see that the smoke does not dissipate by the time it reaches the boundaries. On the top, the difference between 3 simulations here is that the size of the fluid emitter here is that the top one is 4 times smaller than the bottom one, and aside from being smaller, it also emits much less density and temperature just because of the size, not because of the rate. Everything else is exactly the same. Okay, so hopefully you guys have fun. Study the scene, look at the expression, try to add more particles, I mean increase the rate, decrease the rate, change the attribute. You more than welcome. There's practically only one expression that runs here, creation expression, so I avoided runtime expressions. Here I was tempted to, but then I thought I should keep things simple enough. The runtime expression could be used to, for example, to determine a distance of the particle between point of emission and how far it travels. So we could use that distance to determine the magnitude of the gravity field, but then we achieve very similar result with mapping the magnitude of the gravity field per particle to per particle lifespan. If there is a difference, it would be really minimum. All right, that's it for our first mini project. Next week we will start covering another topic that would be the Python programming inside of Maya. We will start with the introduction to the basic programming concept, and we will evolve into writing a custom tool that we will be using later during other dynamic classes of this course. Thank you very much, and I see you next week.